Hello everyone. So myself Prasanna Patil, third year TYB student, TRN 2231084. So I'm going to explain my COBOL assignment that is based on applying if-else logic for decision making and repetition structures, that is perform until for iterative loops. And this we are processing this with a standard mainframe batch environment, so all my explanation will be in intact with the latest IBM Enterprise Doc that is given. So let's start. So the foremost thing in COBOL program is the division we do. So we are having here four divisions. Like you can see, the first division is identification division. Then that is data division. We have environment and procedure division. So these are the four divisions. So let me give it a brief of this. First of all, the identification division is a mandatory division and it identifies the program through program ID, author, and installation date, right? Division is important. All the fields are not important. Okay. So next division we are having is data division. So here we define the variables, the constants, and the data structures used by the program. It contains sections such as, file sections or working storage section. Like you can see, I am having here WS number input. So what does WS means? That's pretty good question. So WS is a common naming prefix for variables defined in working storage section. So that is working storage section to be precise. And this lies in the data division. So what's the purpose of using working storage section? So it describes the data records and independent data items that are created, used, and manipulated during program execution. Okay, so now you can see that I have used here PIC. So let me give it a brief on why PIC is used. It is an abbreviation, a short form of picture, and it is a clause that we can use to define a data type. It is similar to data types in Java, CPP, or any other language. So pick S 9 bracket 4. S defines for the sign input. We are using negative sign here. 9 defines that we can use input the number from 0 to 9, single digit numbers. And 4 denotes the size of the my number. That is from that, just like 4,000 is a valid number because it has having 4 size. 40,000 is an invalid number because it is a size 5, right? Similarly, I have taken another variable, that is the result message. So here I am storing X. So what does X means? X represent any character, including letters, numbers, and special numbers. And 30 denotes the size of that character. So result message could be 30 characters long as well. I have also defined an exit flag and I have allotted X1. It means there is one character value n, whose value is n, whose value is no. This is a control flag which is by default set on no. And I have defined end of session variable as y. So I will make sure that why we are using control flag, that is clear by the end of this tutorial. So, okay. So when we move forward, we see that there is a procedural division. So what does it mean? Here lies the main logic of our mainframe, or heart of mainframe. So you can see I have written display program start. So it means that it is systemout.ln in Java. Similarly, it is display in COBOL. Simply I have declared program start. Then you can see perform 100 process number until end of session. So what does this line mean? This line means that perform the process for 100 times until end of session is achieved. So when will the end of session be achieved? Let's see forward. So I have defined here 100 process number. What it does, inputs, it outputs enter a number with no advancing. No advancing is nothing. It's just about that. our cursor should appear on the next, right? So we are accepting an WS number as input. If so, now the nested loop starts. If the user inputs 4 times 9, this is command to end the session. Let me be clear, end of session. Once the user press 4 times of 9, like uh, quadruple of 9, Y Y is moved in W as exit flag. So what happens? Y is moved in W exit flag. Initially it was N, then Y is moved, and Y is moved, end of session is achieved. So it is a control flag to end the session. Else, if the number is not thus inputted, it can be either three cases. Either it can be greater than 0, less than 0, or equal to 0. So we will check if number is greater than 0, then it's okay. We will print the number is positive and move this into the WS result message variable, and we will just display this variable. Okay, so there this was our COBOL program, and you can see there can be a doubt that why are we leaving this six places initially empty? So, in earlier years, leaving this blank was a common practice and they are typically ignored by modern compilers. The historical reasons for this practice are rooted in the technology used when the language was developed. Like at that point of time, early COBOL programs were physically written on 80 column punched cards. Each card represented a single line of code. So, column 1 to 6 were crucial for keeping the cards in the correct order. And if we stack the cards are dropped, the line numbers allowed the programmers to automate the process. So yeah, so this was for the sequencing basically. And the next area 8 to 11 generally contains the sections, division, paragraph names, as well as other data division elements. So this was the assignment. So let's run this assignment once. So what I will do, I have created a Ubuntu image file in order to simulate a Linux environment in my directory. So I have compiled this using GNU compiler, COBOL open source compiler, and you can see like I have the image of it, if else new. So what I will do, I will simply run this in order to achieve the result. See, our program is ready. Once I input 1, number is positive. Once I input 0, the number is 0. And if I input this, end of program. So this was a quick illustration of how a COBOL program works. Thank you. I hope I have added something valuable to your knowledge, and keep subscribe my channel. Thank you.